Okay, we're going to talk about trig ratios today, section 5.4. Now, if you notice, there's a school net tonight that's got, there's actually two things for school net. You've got 5.4, which has the code. That's extra credit if you do that tonight. So you use tonight's notes, you put in the answers, you're going to need, well, the school net has a calculator built in. I put a calculator into the school net, so just click the calculator button, you'll get a scientific calculator. PT 20, if you were here Friday and Monday, both days, then yours should be done. Because we worked on it Friday and we worked on it Monday. So yours should be done. All you got to do is take the paper and plug in the answers. Pretty much all it is. I asked maybe one extra question about one of the pictures, but that was pretty much it. Most of it's just plug in the answers. It will grade it for you, so you'll know exactly which one you got right or wrong right away. Okay, so you're just going to be plugging those in SchoolNet. That's also extra credit if you do it tonight. You wait and do it later, you won't get extra credit for those too. All right, so just letting you know. All right, let's talk about this picture right here. Do you see three triangles? Okay, you got a small, you got the medium size, and you got the big, large one. Now, these triangles are similar triangles. The reason they're similar is because they all have angle A in common, right? And they all have right angles. So that tells me that the AA postulate lets me know that those are all similar triangles. Now I just want to look at a couple of ratios, but for time purposes we're not going to be able to do all of them. But I want to focus on the opposite and the adjacent. So let's look at angle A. The opposite side of angle A would be this side over here. That's across from angle A. It's called the opposite side. That means it's not touching angle A at all. You see that? Not touching angle A. So over here, it's FB. That does not touch angle A. The adjacent side to angle A is down here at the bottom. So that one is touching angle A. Now this other side is also touching, but it has its own special name. The biggest side of a right triangle is always called what? The hypotenuse. Yes, the hypotenuse. So we're going to just focus on opposite and adjacent for a minute. And I want you to look at these two right here. Opposite side, if we count it on our graph paper, is 3 units. So we're going to put a 3 right here. The adjacent side, if I count it on my graph paper, is 4 units. That is a reduced ratio of the opposite side to the adjacent side. Now, if I made my triangle bigger, I kept the same angle. Angle A doesn't change, but I just extended it out farther, right? If I did that, then what is my new opposite side going to be? 1, 2, 3, 4, 5, 6. I'm going to put it right in this, right here. Opposite would be 6. What would my new adjacent side at the bottom now be? 4 plus 4 would be 8. What would I get if I reduce that? 3/4. Do you see how I get the same ratio? It didn't change. That means we know they're similar triangles because they have the same ratios. But we already knew they were similar because of the angles. The reason I show you this is because trig functions are all based around these ratios. Because this angle A can reduce to the same ratio, the calculator knows that and can calculate that for you. That's what those 3 trig buttons are about. They're about the 2 sides of a triangle. One of them is dealing with the opposite and the adjacent side. One of them is dealing with the opposite and the hypotenuse. And the other one's dealing with the adjacent and the hypotenuse. Now, if we look at the very last triangle, just so you can wrap this up and see that all 3 of them do actually work. If I looked at the opposite side way over here, I'd have B to C is actually 12. You count that and you get 12. A all the way over to C, if you counted that, would give you 16. And what do you get if you reduce by 4 here? You get 3/4. You get the same ratio. Now, one last little side note on this slide, and then I'll move to the next one, is you notice this little triangle? You see how we had a 3 and then a 4 down here? It's actually a Pythagorean triple. Because if I did the Pythagorean theorem, 3 squared plus 4 squared equals c squared, I would end up with a 5 for C. And this length would be a 5 right here. So they'd all be whole numbers, and that'd be a right triangle. So it would be a triple. Just on a side note though, what would my opposite side over my hypotenuse be as a fraction? If I did my opposite side, it was how much? 3. And what was my hypotenuse? 5. 3 over 5. Guess what this opposite over hypotenuse would reduce to? 3 over 5. Guess what this opposite of over hypotenuse would reduce to? 3 over 5. They would reduce to the same ratios. Okay, that's how the trig functions work. Plus, the calculator will know which ones to divide by the two sides that you have. Now, I'm going to skip these just for time purposes, and we're going to move to the next slide. All right, ratios in right triangles. How do we know which button to use? That's the key. Here it is. To use the sine button, you need to have the opposite side over the hypotenuse. In a calculator, when they programmed this calculator, they programmed it that if you hit the sine button, it's going to divide the opposite side by the hypotenuse. Anytime you put in that sine button with an angle, it's dividing the opposite of the hypotenuse. If you've got different sides and you use the sine button, it's not going to work. You want to make sure you use the right button, and if you've got the opposite over the hypotenuse, you've got to use the sine. And the 3 letters, the S-O-H, could help you remember it. So, S-O-H, sine is opposite over hypotenuse.
So the opposite would be the big A and the big C.
Yes, here, well, I'll show you that right here. Look at angle A down here. Circle angle A. I'm going to tell you a little side note here. Anytime you see capital letters, those are angles. And always use capital letters for angles. Anytime you see small letters, those are always sides. Small letters are sides, capital letters are angles. Notice where big A is and where little a is. It's always across. Because big A opens up to little a. So you're going to have to put the little a down here. That's actually the opposite of angle A right there. That's across from angle A. This side over here is actually the adjacent side to A because it's actually touching A. It's the leg that touches, so it's adjacent. And then, of course, this side right here is your hypotenuse. So you've got your opposite, you've got your adjacent, you've got your hypotenuse. Now, if we're looking at the sine function right now, sine is opposite over hypotenuse. What 2 little letters do you think I would put there for the sine of A? What 2 little letters would be the opposite over the hypotenuse? Opposite would be little a, hypotenuse would be little c, so it would be little a over little c would be my sine of angle A. If I knew those 2 numbers, I could divide them. I'm just showing you which sides they are right now. Cosine, in your calculator, the cosine button is the adjacent side divided by the hypotenuse. Adjacent over hypotenuse, AH. So we call it CA. C-A-H. CA, C-A-H. Cosine is adjacent over hypotenuse. You got to remember AH because the A's got to go on top, the H has to go on the bottom. That's what the calculator is dividing. So what 2 little letters would be my cosine down here? What's my A? Is little b, right? And my H is little c, so it should be little b over little c for your cosine. Your adjacent side over your hypotenuse, b over c. Now what's left over for tangent then? We've got opposite hypotenuse, we've got adjacent hypotenuse, opposite and adjacent. That's what's being divided by in the TOA, the tangent button, so we have TOA. Opposite over adjacent would be TOA, T-O-A, opposite over adjacent. Now that's your famous Indian chief. His name is Chief Sokatoa. And if you remember his name, you'll always know which button to use in your calculator. Sokatoa. You can say it to yourself so that way you know if it's OH, you've got you've got sine. If it's AH, then you know you got to use cosine because you got adjacent and hypotenuse. And then if it's OA, if it's TOA, you're gonna use tangent. Now, what would be the tangent for angle A down here? It would be A over B. That would be the opposite over the adjacent, TOA, TOA. Okay, let's look at one of these. Now, this is messed up right here. List the sine, cosine, and tangent of each acute angle. You can't do sine, cosine, and tangent of a right angle. It does not work. If you put it in as a right angle, it's going to say invalid or error. You don't put it in as a 90. You've got to use acute angles. So if I circled angle A right here, if I circle angle A, then what do you think is my opposite to A? 12 is. That's the opposite. What is the adjacent to A? The 5 is actually touching A. That's where it's the leg that touches is adjacent. And then this has to be my hypotenuse. So what numbers would I put here for the sine of A? Opposite side is 12. Adjacent side is, not adjacent, I'm sorry, hypotenuse is 13. So that fraction would be 12/13. So you'd have the sine would be opposite over hypotenuse, which would be 12/13. Cosine would be, now remember this was opposite over hypotenuse, so it's SOH, so. Cosine would be adjacent side, which is what? 5, and hypotenuse, which is 13. That's adjacent hypotenuse, CAH, ka. So, ka, and then the last one is TOA. So what's my opposite side again? 12, what's my adjacent side? 5, so that's my opposite over adjacent. So, ka, TOA. Now let's switch gears. Let's get rid of angle A, and let's circle angle B. Oh, but is this my opposite to B over? Is this my adjacent side way over here? No, if I'm circling angle B, I've got to erase this one and this one. Do I need to erase hypotenuse? No, because hypotenuse is always in the right triangle. So this one is now your opposite. Your opposite changed. Your opposite and your adjacent switched because you went to the other acute angle. So what is the sine for angle B now? If I'm using angle B, what would be my sine? 5 opposite over 13 hypotenuse, 5/13. What would be my cosine for this angle down here, angle B? 12 is my adjacent over 13, 12/13. And then my tangent, my TOA, TOA, OA would be 5 over 12. What do you notice is the relationship between the sine of A and the cosine of B? Sine of A is here, cosine of B is here. What do you notice about their relationship? They're equal. Why are they equal? Why would they both be 12/13? Because when you switch acute angles, what happened to the opposite and adjacent? It switched as well. So when you're switching the acute angles, you're switching the opposite and adjacent. That means you're switching from sine of A to cosine of B being the same. And then what do you think about cosine of A and sine of B? What do we notice about these two? They're also the same, yeah. So they're also equal. Now I do want you to recognize something on here. 12 over 13 and 5 over 13. This would be almost 1. It'd be like 0.9 something, right? This would be like almost a half. It'd be like 0.4 something. What do they both start with? 0 point something, right? Does the sine and the cosine always have to start with 0? Because tangent does it. Look at 12 over 5, that's like 2.4. Do sine and cosine always have to start with 0? And then it does, but why? Okay, what's always on the bottom in the sine and the cosine? The hypotenuse. What do we know about the hypotenuse? The biggest side. If the biggest side's on the bottom, then your fraction has to be less than 1 whole. So your sine and your cosine will always be less than 1. If you try to put a sine being greater than 1, it's going to say error. It won't let you. because it doesn't work. Sine can never be more than 1, and cosine can never be more than 1. So those are always going to be less than 1. Tangent, if you notice between the two, what do we notice about the tangent? Tangent of A and tangent of B, they just reciprocal, right? You just flip them. So it's just a reciprocal. All right, we're going to do the construction later. We're not going to do it now. Solve for x and y using trig ratios and the special right triangle formula. All right, well, we already learned the formula. We learned about a 30, 60, 90 right triangle. So 30, 60, 90. We had two formulas. Now in this triangle right here, here's my 30-degree angle. It's angle B. This would then have to be my short leg because it's across from the smaller angle. This would be the longer leg. This would be my hypotenuse, always across from the right angle. Does anybody remember the formula to go from short leg to hypotenuse? It's double, so hypotenuse equals 2 times the short leg. And in this case, x equals 2 times 6, which is 12. So that was pretty easy to find x, right? But let's try it with the trig ratio. Let's see if we still get a 12. We will, because we know trig works. But if I'm looking at my trig ratios, this angle, this 6 is the opposite side, right? It's across from 30. X is my hypotenuse. Which one has opposite and hypotenuse? O and H. OH. So, S-O-H. So which one do I have to use on the calculator? The sine, the S-O-H, right? So the sine of 30. Sine of 30 equals the 6 over the x. The opposite side over the hypotenuse. OH. SOH. How could I solve that for x? Okay, multiply by x on both sides? I would. I'd get rid of the x, right? It's on the bottom. I don't want the bottom. But could you find what this is in your calculator first? How much is the sine of 30 in the calculator? 0.5. You put in sine of 30 in a calculator, you're going to get 0.5. You know why? What's the ratio between short leg to hypotenuse in every 30, 60, 90? A 1 to 2 ratio, right? What does 1 over 2 reduce to, or what does 1 over 2 become as a decimal? 1/2 or 0.5. That's why the sine of 30 is 0.5. Because it's always going to be a 1 to 2 ratio. So if you put it 0.5 equals 6 over x, put a 1 under it and multiply your diagonals, you get 0.5x equals 6. Divide by 0.5, you're going to get x equals 12. Do you see how we got the same answer? Which one was quicker? Which one was easier? The 30, 60, 90s, right? If you remember these formulas, it's a lot faster. Do you have to remember those formulas? No, you just have to know the SOHCAHTOA. If you know the formulas, you're going to save yourself time. If you don't know the formulas, you just use trig and you get the same answer. So you can do it either way. I'm just telling you, the formulas for those special triangles, it helps you a lot. All right, let's try trig on this bottom one now. We got a 45-degree angle. This x over here is my opposite side. The 7 is my adjacent side, and the y is the hypotenuse. Opposite hypotenuse, OH. Which button is OH? OH. So, S-O-H. So, right? So, sine of 45 equals the x over the... Oh, wait, I don't want hypotenuse. I'm sorry. I'm not trying to find y yet. I'm trying to find the x, and I got a 7. Sorry about that. So, O-A, TOA, T-O-A, right? So we got the O is the x, and the A is the 7. So tangent. Tangent of 45 equals equals the opposite side x over the adjacent side 7. So that's a trig equation that we could solve. And I'm going to tell you one thing, when the 7's on the bottom or the number's on the bottom, it's a lot easier. Because all you have to do is times by 7. And if you've got one of these calculators, I don't know how the SchoolNet one works, if it lets you put it straight in or not. You might have to put in tangent of 45 first and then times it by 7. But I can do 7 times tan of 45 straight in the calculator. Put it in, and then I get it equals. It does the whole thing for me, and it gives me a 7. How is that a 7? What is the tangent of 45? Does that equal a 1? Oh, it does equal 1, huh? Because what do I know about two legs in a 45, 45, 90? The two legs have to equal. This better have been 7 or we would have messed up. So you can see that the trig worked. It gave us 7. Now to get the hypotenuse, the y, I would use cosine. Cosine of 45 equals 7 over y. Do you know why I use cosine? Adjacent side over hypotenuse. AH. So, ta, toa. C-A-H. C-A-H would be so, ka, toa. What's up? Okay, so this time we've got to get the y by itself. So this one's a little tougher. If I put in the cosine of 45 in my calculator, I get 0.7071. I'm going to put 4 decimal places. 4 decimal places makes it a little bit more accurate. That's just taking this and converting it to a decimal. That's all I did. I just put it in the calculator. Cosine 45 equals, and I got a decimal. Now I can cross multiply if I want to. So I get 0.7071y equals 7 times 1, which is 7. If you divide on both sides, you're going to get 9.9 as your hypotenuse. This piece up here is 9.9. Do you remember your 45, 45, 90 formulas? Hypotenuse equals radical 2 times a leg. Radical 2 because there's only 45s and 90s. So it's just radical 2 times a leg. Alright, so hypotenuse is our y value, equals radical 2 times 7. So you've got 7 radical 2. So you got, these are both 7s, this would have to be 7 radical 2. What do you think happens if you multiply 7 times radical 2? How much do you think you get? 9.9, which is exactly what we had here. So you're going to get the same answer either way. It's a lot quicker if you know the formulas for 45, 45, 90. That'll be faster, but not required. You don't have to memorize it because we know trig. And if you know SOHCAHTOA, you can solve anything. Any right triangles you could use SOHCAHTOA for, and you have it at the end. All right, let's look at a couple of real-life scenarios. Real-life examples. If you've got this tree right here, and you want to find out how tall it is, I've got a 59-degree angle. What does this 45 represent as far as the sides go? This is the adjacent side. It's touching 45. It's the leg that touches. And what is this h? Is that a hypotenuse? No, that's the height, right? Which is my opposite side in this case. Opposite adjacent. So who knows what trig function we have to use? What button would I need to push in the calculator? Sine, cosine, or tan? No, not sine. Try again. Tan is right. T-O-A, TOA. Remember, you might even want to write on each page, TOA, so that you can see, okay, I've got O-A, 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 oh, there it is, O-A is TOA. So you put tangent of 59 equals the h over the 45. And again, it's really nice when the number's on the bottom. So you're going to multiply both sides by 45. These 45s will cross out. H equals, adding straight in the calculator, 45 times tangent of 59, just like it says. Boom, we can plug it in, it equals 74.9 feet would be your answer. And it does make sense because this angle up here would be about 31 degrees. And so 45 better be the smaller side. 74.9 is bigger because 59 is bigger. So this height would be 74.9 feet. Now there's an escalator at Wilshire, Vermont Metro Rail Station in Los Angeles, and it rises 76 feet at a 35-degree angle. That means from the bottom straight to the top, the height would be 76 feet. The escalators would be going up at a 35-degree angle. So circle the 35. It's good to circle your angles. That means this side over here is called the opposite side. It's not touching, it's opposite. This B is called hypotenuse. We don't need adjacent, so we need the O and the H. They want to figure out how long are you actually on the escalator for, or basically how far are you traveling on the escalator. So we're going to use which function? Sine. Good. Sine of 35. Opposite over hypotenuse. OH. Right up here at the top here. SOH. So the sine of 35 equals 76 over D. Well, this time the D's on the bottom, but we can still solve it. I could find the sine of 35 on my calculator. I get 0.5736 equals 76 over D. I could put a 1 under it. I could cross multiply to get 0.5736D equals 76. Divide it on both sides. And if you take 76 and divide it by 0.5736, you get 132 and a half feet. 132.5 feet. That's how long you would be, how long you travel on that escalator. You'd actually be going 132.5 feet from the very bottom of the escalator to the very top of the escalator. Here's a quick review. Take a look at this little problem right here. I know it's a small one. Take a look at it real quick. And see if you can figure out the other two sides. To me, you might be able to figure it out really fast. 30. So what's this angle right here? 60, 30, 60, 90. I have long leg. How do I get short leg? If the long leg is 18 radical 3, then what did the short leg have to be? It had to have been 18 because short leg times radical 3 is long leg. Short leg times radical 3 is long leg. So if this has a radical 3 next to it, then the short leg must have been the number in front. So that's 18. What's the ratio from short leg to hypotenuse? 2-to-1 ratio or 1-to-2 ratio. So what's my hypotenuse, the biggest side? 36. You double it, the short leg to get your hypotenuse. That's just a quick review. 18 radical 3, 18 up to 36. Those would be your three sides. Look at them, see if you can understand their little formulas. If you do, it saves you time. All it does is save you time. All right, last page here. Find the values of x and y. Okay, so x and y. Let's circle the angle, 23 degrees. Across from it would be my opposite side. Next to it, touching it, would be the adjacent. That's the leg that touches. The hypotenuse also touches, but that has a special name, hypotenuse. Let's solve for x first. O, H. O, H. Remember my Indian chief? So, fa, so. So, katoa. So which one do I use here for the x? I gotta use sine. Sine of 23 equals the x over 34. Have to use sine on that one because you've got O and you've got H. S-O-H, so sine. Times by 34 on both sides. Nice when the number's at the bottom because you can just multiply 34 times the sine of 23 straight in your calculator. And you get 13.3 is your x. That's over here, 13.3. Now, who can tell me what trig function to use for y? There's actually two possibilities. We could also use Pythagorean theorem, couldn't we? Now we have two sides. I could do a squared plus b squared equals c squared if I wanted to. But I think the trig would be faster. I think the fastest one right now would be cosine. Now, what would be my fraction for cosine? What's the calculator going to divide for cosine? Adjacent y over hypotenuse 34. And the reason I think that's the quickest is it's got the number here on the bottom. And you can just multiply by 34 on both sides. And 34 times the cosine of 23. And you get 31.3 right here. So y equals 31.3. And that would be down here. Is that across from a bigger angle? Yeah, because this angle up here is going to be like 67 degrees. So that's definitely across from a bigger angle, so it's got to be a bigger side. So that did come out right. Now look at this one. Underline the word area. Area equals base times height divided by 2. We're going to get more into area formulas later. But that's a one that you should already know from way back in your last few grades. Base times height over 2 is the area of a triangle. Right now, I know the base. That's what I have. So I have 11. I don't know the height, and I do know that I'm going to divide by 2. So I need to find this height right here, this h for height. This h is the opposite side of my 33-degree angle. Opposite, and this is the adjacent side of my 33-degree angle. Opposite, adjacent, OA. Which one do I got to use? TOA, so TOA, so tangent. Tangent of 33 equals the h opposite over the a, 11. Multiply both sides by 11. And you could do 11 times tangent of 33. And you get 7.14 is your height. Now be careful because if you put that in as your answer, you got it wrong. You forgot to do the last step. Plug it back into your formula, 7.14. If you write out the formula, you might remember to plug it back in, so I would encourage you to write it out. 11 times 7.14, and then divide it by 2. 39.3 is your area. And it would be square units. Units squared. Helicopter flying over a building when it's spotted from point B 300 feet from the building. The angle at point B is called the angle of inclination. It's a 60-degree angle. It's called the angle of inclination because it's the angle of you looking up. So it's a 60-degree angle. The angle is, what is the altitude? So how high is the helicopter at that point? They're telling you you're 300 feet away from the building. Straight up is your helicopter. You're looking up at a 60-degree angle to see it. This is the opposite side to my 60-degree angle. This is my adjacent side to my 60-degree angle. OA. OA is which one? TOA. I could do tangent. TOA. Tangent of 60 equals the x over 300. And I could multiply both sides by 300. And you get 300 times the tangent of 60. 519.6. Now, what kind of triangle was this? It was a 30, 60, 90. Was there a shortcut to finding that answer? Could I take, to get my long leg, isn't this a long leg? And this the short leg down here? Isn't it short leg times radical 3 to get my long leg, because there's 3 different angles? Couldn't I have just taken my 300 and multiplied it by radical 3 in my calculator? And I would get the same answer, 519.6. So you can save yourself a little time if you use the shortcut. Now again, trig is easy. Trig is, once you figure it out, once you know so, the ka, the toa, and your calculator, it's all calculator work from there. It's not like you have to figure anything out. You just got to know which button to push. If you can figure out which button to push, the trig will come really easy. You just got to know what two sides you have, and then you got to use the tangent button in this case. All right, last two are just multiple choice ones. They're really fast. Let's see, circle 25. This is your opposite side, and here's my adjacent side. And this is my hypotenuse. And it says, use the diagram to find CD. CD would be X here, right? So opposite over hypotenuse. What would I use for opposite hypotenuse? Opposite hypotenuse. I'd use sine. Sine of 25 equals the 8 over the X. Okay, now I don't see that anywhere. So let me get X by itself. Let's multiply by X. So we have X times the sine of 25 equals 8, and then we got to divide by the sine of 25. So do you see one that says 8 divided by the sine of 25? That would be letter D right here. Letter D. All right, well, we'll stop there. Okay, the last one here says, which expression is not equivalent to AC? Here's AC right here. And if this is 160, this has to be a 20-degree angle. Circle that 20. This would be my opposite side, the AB. My adjacent side would be AC. And my hypotenuse would be BC. Now, if I'm looking at these answers, I'm looking at these middle two, and I'm thinking, wait a second, both of these pieces cannot be over the tangent of 20. So I'm going to be looking at my tangent of 20 function. So tangent of 20 equals the opposite over the adjacent thing. AB over the AC. AB over AC. And we want to get AC by itself. So if we multiply both sides by AC and then divide by the tangent of 20, these cancel out. You're going to see that AC equals AB over the tangent of 20. So AB over the tangent of 20 is right. That's what this is. They want to know which one's not equal to AC. It's got to be this one, because BC would not be over the tangent of 20. AB would be over the